Earlier on, we have discussed a few concentration time graph questions, and so here we are looking at the rate concentration graphs. Rate versus concentration graphs, how do we come about with this? Well, we will actually be able to do it by using be it discontinuous method or continuous method. Discontinuous method means that the clock reaction, we use that short average rate for short duration as a close approximation to the initial rate, and then we do multiple of them. So we have rate at different concentration, then we plot a graph. Continuous method, we will have to track multiple set of experiment and or get the multiple initial rates from the graph. Uh, so over here, if you look at your discontinuous method, which is the clock reaction, we will vary one of the factor and then we will vary the concentration, of course, so that we can end up plotting the graph of rate versus concentration of A. So typically you'll be thinking of the data table will look somewhat like this. So the different concentration and then you have different rates, right? So that will translate to one graph of rate versus concentration. If we were to use a continuous method, then we'll vary A with our initial concentration B being constant so that we will plot. And yes, every line is one experiment, and then we will draw gradient at time equals to 0 for all the lines that we have to get the initial rate. Then we'll be able to have the graph of initial rates versus concentration of A. So when we plot a graph of reactant against time, determine the gradient of the tangent to the curve at various concentration, where the gradient is actually directly proportional to the rates of reaction. So plot a graph of rate of reaction against concentration of reactant is possible. So there are two ways to do it if you look at it here. So if you have a rate versus reactant graph, that is a horizontal straight line, that's a zero order. If it is a linear line with a positive gradient, then we have in first order. If we have second order, then it might look like that, but it is not conclusive for us. We need a straight line. So with this case, we will actually have to plot graph of perhaps rate of reaction against reactant square so that we can draw a conclusion. If we manage to get this graph, then we are happy to conclude that it is the second order. So I'm going through this so that you know how we can draw the conclusion. I've gone through these in the earlier parts with respect to the rate equation, so you can look at them again if you feel lost when I'm going through this portion of it. The numerical k value can also be obtained from the appropriate graph. So for zero order, the k will be the y value, whereas for the rate, the k will be the gradient. For second order, then this is it, the gradient of the rate versus reactant square graph. Quite simple and straightforward. So let's look at the example here. You have a reaction between magnesium and hydrochloric acid, and we have a concentration time graph first. Later, we have the rate concentration graph. So determine the order of reaction with respect to HCl. Gradient is not constant. It is not zero order with respect to HCl. So we are looking at perhaps first or second. So to determine the instantaneous rate at various concentration, we will actually need to draw a tangent at the time. So say for example, like this case, if we only do one set of experiment, which is the third scenario that I run through earlier, we will have concentration equals to 0.7. So we read across the graph, draw a tangent there, then we will get the rate at the point. So you get the rate at different concentration accordingly. So like what I've shown you in your notes, if you were to have these three graphs being plotted, rate versus concentration of HCl, it is a curve. It is not first order with respect to HCl. That's the first conclusion you can draw from this graph. When we have this graph, rate versus concentration squared, then we know it is a straight line. it is second order with respect to HCl. And then when we do the rate versus concentration cube graph, then you know that it is not a third order with respect to HCl. The purpose of this example really is to highlight to you how you can use the rate versus concentration to the power of n graph to draw conclusion. Basically, we are looking for a straight line linear graph.